Hey, hello there. Today's notes, we'll be taking a look at a new unit, reaction types today. So Unit 9, done with organic chemistry, on to reactions. Oops. In this unit, there are 5 types of chemical reactions that we're going to take a look at, we're going to study. Today we're going to go over the first 2 of them. But in general, for all 5 types, do these steps. Now, first of all, you're going to want to identify which type of reaction we're looking at, and we'll talk more about that as we go. But after that, then, your first step is always to write the formulas. With, and this is very important, write the formulas with proper subscripts. We started the year kind of looking at how to write formulas with subscripts. So let's just say we have lithium oxide, LiO. We would take a look at our periodic table. We find lithium, alkali metal. This first column here has a +1 charge. Just put a +1 above him. Oxide, over here, it's a -2 charge. Start -2 over here. Now, if you see it right off the bat, that's fine. If you don't, you can always cross over. But we're going to need a 2 behind this lithium because we'll need 2 positive charges to cancel out the -2 of oxygen. That 2 is a subscript. So there's a subscript. That is our subscript. Always make sure that you're writing your formulas with proper subscripts first. In fact, if you're ever struggling to balance a chemical equation, go back and check your subscripts. Chances are you very well may have made a mistake there, and that's what's making it impossible to balance. So always double check that you have the correct subscripts first and foremost. Then balance with coefficient. We haven't worked much with coefficients yet, but you've probably seen them before. The coefficient is the number that's out in front of a compound or element. So the subscript is the little number that is typically behind one element or group of elements. The coefficient is the number that's out in front. So use those to balance for the overall equation once you have all of your subscripts in the right place. And then finally, list the states of matter. States of matter matter. The rules here are, if you're working with an element, most are solid. So if you can't remember exactly what you're looking for, most elements are solid. So if you have to, guess solid. Two are liquids. Oh, and I forgot to mention, I think you guys will figure this out pretty quickly. We use S for solid and L for liquid. There's only 2 naturally occurring elements as liquids on the periodic table. So get yours out and let's mark these down. The 2 naturally occurring liquids are mercury, a little cursive L there, and bromine, also a liquid, as an element. So those are the only two liquids. Again, most of these guys are solids. And then a handful are gases. And guess what letter we use for that one? G for gases. Makes pretty good sense, I hope. All right, so there's a handful that are gases, and you probably already know them if you had to wager a guess. Nitrogen, there's one gas. Oxygen, I bet we all knew oxygen was a gas. Fluorine, chlorine. Now, the noble gases here, they're all gases. It's implied in the name, noble gases. But here's the thing. They don't react. They're not going to be in our chemical reactions. We're not going to write them. I'm not going to worry about them. Plus, if they ever are, which they won't be, but if they ever are, they're called the noble gases. So yeah, we know those guys are gases. We're not concerned with them. It's these four. And then don't forget about hydrogen up here. Top left corner, hydrogen, also a gas. But otherwise, most of the elements, vast majority of them, solid. So that's hopefully not too much of a trick for you. How about compounds? Well, it kind of depends on whether you're working with an ionic compound or a covalent compound. So remember this from last chapter. Ionics are almost always solids, especially in decomposition or synthesis reactions. So identify what type of compound you have. If it's an ionic, it's a solid. Covalent compounds, two nonmetals, they're usually gases. One big exception, but I'm sure you guys are all aware of it. Water is usually a liquid. We'll talk about a couple times he's not later this unit, but watch out for water. He's a liquid. Otherwise, most covalents are gases. There are some covalents that are not gases. That's true. But I'll tell you guys that. I'll make sure you guys are aware of that when you're going into a problem. So as you take a look at the homework problem, and if it's not a gas, for instance, butane, perhaps I'll give you butane. Butane is a liquid. So the problem is read as liquid butane reacts with whatever it's reacting with. So as long as you're reading the statement then, liquid butane, you know the state of matter of that covalent that isn't a gas. So otherwise though, if it's water, put liquid. If it's a covalent other than water, put gas. All right, so that gets us started with the rules. Let's take a look at our first unit in this chapter. So 9.1, we're looking at synthesis and decomposition reactions. So synthesis and decomposition. Their names pretty much tell you exactly what the type of reaction they are. We'll start off with a synthesis. So in the synthesis reaction, two or more substances are going to combine to form a new substance. The general formula you're going to look for: A plus B gives us AB. That's how we know it's a synthesis. Synthesis means to make, so we're combining two things to make something new. An example of a synthesis reaction, something you might see in your homework over the next couple of days here. So write a balanced chemical equation for the synthesis of copper and sulfur to form cuprous sulfide. All right, so here's our A, copper, plus our B, sulfur, to form AB cuprous sulfide. So copper, I'm going to leave plenty of room. Remember, I've got to put states of matter, potentially put some subscripts, put a coefficient, so plenty of room. Copper plus sulfur in plenty of room yields cuprous sulfide. Is the fact that it's cuprous important? Absolutely. On the back of your periodic table, copper could form two different ions, either cuprous or cupric. We're working with cuprous, which has a +1 charge. Sulfide off the front of the periodic table has a -2 charge. So when we balance those charges, it's going to take 2 cuprous to cancel out our 1 sulfide. So there's our subscript in there, Cu2S. That's the difference between cuprous sulfide and cupric sulfide. Before we move on to balancing for coefficient, let's double check. We've got elements by themselves. Are they diatomics? Always make sure you do that. Always, always, always. If you forget a diatomic, you're going to give yourself a headache on trying to balance. So our 7 diatomics are Hofbrinkel, so H, O, F, Br, I, N, Cl. Hofbrinkel. Neither Cu nor S was in there, so no subscripts for these guys. All right, that brings us to balancing then. We'll use coefficients to do that. On this side, I've got 1 copper. Over here, I've got 2 coppers. That's what the subscript there tells me, 2 coppers. So to balance this, I'll put a 2 in front of copper. Over on this side, I've got 1 sulfur, 1 sulfur. So hey, that one's already balanced. We're in good shape. And that means we've got a balanced chemical equation. 2 coppers, 1 sulfur, 1 sulfur. Awesome, fantastic. Time for the states of matter. Again, pretty much everything's a solid. So when in doubt, guess solid. Yep, didn't put anything up for copper, so that's a solid. Same with sulfur. He's in the middle of the gas land, but he himself is not a gas. So solid. Solid. Ionic compound. Solid. One last thing. These charges, I don't want them there. Compounds are neutrally charged. This makes it look as if we've got positive and negative charges on it, and we don't. So I need to erase those. I write them. I think that they're very beneficial when I'm balancing and figuring out what subscripts to put. But when you're done, get rid of them. Don't want them in your final answer. I count you a point to keep them there. So there are synthesis reactions. Now let's take a look at decomposition reactions. Sorry about that. When they break down into products, not necessarily compounds. So sorry about that. These are, in general, the opposite of synthesis reactions. So general formula. You have one product and it's going to fall apart into two products. One reactant, it's going to fall apart into two products. Again, pretty much the opposite of what we saw up here in a synthesis reaction. So an example here of a decomposition reaction, hydrogen bromide decomposes into its elements. So we'll start with the hydrogen bromide part. Hydrogen bromide. Can leave a little room for states of matter, subscripts if we need them. It's going to break apart into its elements. That would be hydrogen and bromide, Br. So there's our A, B, and there they're separated into A and B. Let's balance for subscript first. Always make sure you're doing that first. So hydrogen, he's not a metal, but he behaves like the alkali metals. So he's got a +1 charge. Bromine, he's a halogen. He's got a -1 charge. So that makes it pretty simple. 1-to-1 ratio. I don't need to put any subscripts. We're in fine shape. Let's check these though. Are either of them a diatomic? And they're elements by themselves. So do they fit in with the diatomic 7? The answer is yes to both of them. These are both diatomics. Hofbrinkel, 2, because of the nature of H, it's diatomic, and Brinkel, Br, 2 for that one as well. All right, so there we go. Now we've balanced for subscript. Let's balance with coefficients. Starting with H, 1 on the left. I've got 2 on the right. That's what that little subscript 2 tells me. So there's a coefficient 2, put it out in front. Now I've got 2 H's and 2 H's. We're in good shape. Now this 2 also applies to Br. That's what a coefficient does for you. It applies to the entire compound. So 2 Brs. Hey, that works out though. 2 Brs. We're in good shape. States of matter, H and Br. That's a covalent compound. I know H is over on the left, but he's kind of the oddball. H is not a metal, so it's a nonmetal. And the nonmetal makes this a covalent compound. We'll call it a gas. Hydrogen, elemental hydrogen is also a gas. And then bromine, elemental bromine, that's one of our 2 liquids. So we add the L for liquid. Finally, get rid of these charges. I don't want to keep them. It's going to cost me a point every time I do keep them. So I erase them. They helped me while they were there, but now I don't want them. There is my final equation for the decomposition of hydrogen bromide into its elements. All right, tomorrow we're going to cover single displacement, so I'll see you there.